right. Welcome back to Hardware Design and Rasterization Part 5. So we've been working on the bounding box iterator. Sorry for the hiatus last week. There are some unavoidable conflicts, so I had to skip a week. So what's going on this week? Well, so let's see. So I think we were in the middle of building the counter. So let's just take a quick little look. Yeah. This params, dimension equals 1. And then, do we have dimension equals 2 working? So we have something compiling. So yeah, so I guess it is not currently working. Good. So this is where we were at last time. We have our counter. We need to figure out what is going on. So let's see exactly where we ended up. All right. We need to fix the tests using the last count. So what do the tests look like when we unroll them? All right, so it looks like we're unrolling. Good. Count 0 equals LB0. And then I think the issue is that these wrap1 tests are the ones causing pain and suffering. All right, so what that means, so we're still, I'm still in the mode of trying to figure out what exactly I didn't quite get correct. So let's see. So theoretically, the 0 test should work for the most part, even if we're two-dimensional. The only thing is that at the boundary of the loops, it should be really angry at us. All right, so we could Emacs minus fn mono, let's say 14 simv.log. Good. So we have, all right, so we have some offending as we do the transfer. All right. Yep, and then we have an offending as we loop back. So it appears that when we turn around, that's causing an error. Okay. This seems to be a theme. So now I'm looking through to see, because it looks like right now we're only doing one loop iteration. Yeah, so it doesn't ever seem like we get a new upper and lower bound. So what was the original bounds? So originally we loaded, so we loaded 188 to 318, so that's not even the right display. All right, so that's part of the problem. So we should probably display what's going on. Yeah. So this looks right if $d is equal to 1. So if $d is equal to 2, we'll do this. All right. So let's write it, will be 1. As long as we're somewhat consistent, hopefully we don't confuse ourselves too much. All right, so we'll do that. I suspect that we actually want to run for a bit longer, or that we want to guarantee our loops are a little bit smaller. So right now our loops could be as big as, so that's 2 to the 8, so like 256 by 256. No, so this is, so we have sort of small numbers here, but so let's make our boxes really small. So we'll have more boxes of limited. We'll make them a little bit bigger. Okay. So this is just, you know, using the bottom 5 bits. This is using the bottom 8 bits of random to build what we're trying to do. All right. And then, you know, if we were building better tests, we might think about how we get better versions of that. All right. So we're going to kill that because we're done with that. All right, so now we're going to run. All right, so far we've spotted, ooh. Let's see if we can spot the issue quick before we forgot to close this. I think it's else if is how that works. It'll yell at me in a second. I believe it. If I wrote it wrong, it'll parse and it'll yell at me, but no, looks like I wrote it right. All right. All right, so hopefully I saw more interesting things happen. All right, so this will tell us what we loaded. So it looks like we loaded that guy, so normal 6:15 alarm. So 188 got loaded to 33, and so we're going to iterate from that to that. All right, so 188, 189, 190, come back. So this is good. 33 to 47, you know, that could eat up a little bit, but you know, we should see it change. Yeah, we did good. We do see it. 34, 47, good. And then row, it looks like we have another bug here. So it looks like we have a couple things going on. So 0 should overflow if not last. So we need to fix the tests using the last count. So 0 should overflow if not last. Good. So we need to fix those tests. And it looks like we have a hardware issue where we don't load the new bounding box is what it looks like we're getting wrong here. Yeah. Yep. So for some reason we kept 188 but copied over 196. So there's some issue with that. Okay. Now let's take a peek and see if it's not obvious why it doesn't get transferred over. All right. So when do we put LB in here? Well, so we put LB. Excuse me. When bound enables high. Bound enables high when the boundary's valid, and we're last. Good. So in the 2D case, what we're seeing is that my child counter is updating because we put the one in here. So this one is getting to last and going there. Your last and my last. So they took the new bound on last. Yeah, so this is interesting. So BB in last. Good. Good. So for some reason, your last is fine. My last is not high. So how do I calculate my last? So count equals my upper bound equals 0. All right, so did we not hit that in the simulation? So we're looking for 46. All right. So 188. Yeah, okay. So what's going on here? So we're getting 188, 46. 188, 46, 188, 46. All right, then we get an increment. So we get 190. good, and then we get another increment, so we go back to 188.47, 188.47. Ooh. So the issue is we're launching too early. So as soon as this one goes, oh, okay, that makes sense. So what's happening, and this is maybe the clever folks who are watching this, is that the outer loop counter is hitting its my last, and it's going last equals my last. So really what we need to do is we need to update its bound valid with something, so so that it doesn't grab the new boundary right away. So that might be one way to solve this problem, is that we use BV to prevent it from latching something unless it is actually last. Oh, now does BV play with last at all? So bound enable, and then does bound. So it looks like they're separated. So if I calculate BV in terms of the last, I shouldn't get in too much trouble. All right, so I suspect what this is that this is boundary valid. So it's both BV and last. And this is my hypothesis that BV will prevent bound update. And this is one of the dangers of doing the recursive thing, is that in the flat version it'd probably be really easy to just blanket write the condition. You know, if I wrote this serially, because one way I could have done this is just written a loop that goes, oh, okay, you know, here's the code for the 0 dimension, here's the code for the first dimension, and I just keep running that code. All right. Let's see, good. So we're loading the same thing again. This 188 to 190, the 33 to 47. So we should be able to scroll down. Not too fast. Great, great, great. 190, 147. Good. And so this is going okay. 190 to 47 turns into 218 and 61. Okay, so we fixed that. So oops. So that was a correct hypothesis. Wow, what did I do? So it's update bounds on valid and global last. Yeah, and if I was being a little more this isn't my BV, this is your BV. Going with our convention that our child is called your, right? So you know your dad really loves you when he calls you hey you. We do this, bam, good. So part of the reason to do that is that if maybe I assume this is wrong later and I want to look at it in the waveform viewer, it's really hard to look at BV and last. At least the last time I played with the waveform viewer, it didn't let you look at the signal directly. But I can look at your BV, so that's why I'm doing that. Alright, so now we need to fix our tests. So that, there we go. So we commented out these tests. Alright. So this is the no increment case. And then I think we have two increment cases, right? Is the normal increment case and the special increment case. So in the normal increment case, this stays the same. So this isn't the no increment case. This is the new bound case. New bound case. So what was LL? So last. This is last cycle's last. Yeah. So if it is the last. All right. Yeah, so this is the new bound case. So hopefully this isn't the one triggering. So what's the one that it's yelling at us about? So it's yelling at us about the +1 case. And it's yelling at us about the +1 case every time we go from 190 to 188. So it's upset about at us about the overflow case. Okay. So let's see. So we have a normal increment case. And then this is, then we have an overflow inc case. Good. This one similarly has an overflow increment case. And then we should check that it's a non-increment, and that count 0 is greater than equal to last lower bound 0. Count 0 is less than equal to last upper bound 0. Cool. Valid. just to make sure that we're getting those. Create new versions, and then I think it's, I think we say if BV and last begin and to grab those, and I already forgot, did I put the last in front or the last behind? I put the last in front. Alright, so now we have last LBs, last UBs, so now we can test to make sure that we're at least inside the bound that was latched. So good, that's done. So I don't need to worry about that. And then this, we need to fix these. And we need to fix this. Oh man. Okay. So I think the invalid count case is still good. So that's the we didn't increment or decrement case. All right. So the overflow increment case. So overflow 0 increment. Assert. Reset or, so this is one of the cases where increment should be high. This is one of the cases where count should be valid. It is not last. Count 1 is equal to last UB And then we're saying last count this, in the normal increment case, we're saying that count 0 equals that's what we're saying, last count equals last upper bound 0. So this is getting kind of sloppy. Right, so in this case, we're saying if last count is equal to the upper bound, then this is a true statement. Otherwise, this needs to be true. So then, the other one needs to be, if last count does not equal last upper bound 0, or count 0 better be equal to last lower bound 0. So I think that's right. So let's make ourselves some bits. Because we could be doing a lot of these. So what we really want to know is at last. Yeah, just like the song. So we'll have a bit that represents that idea. So I'll actually say, I already forgot, did I have an underscore? At under last, okay. At last 0 is equal to last count 0 equal to last UB 0. Good. Now I complete this with not at last 0. I can replace this with at last 0. So we're gonna align these a little bit so they look like they're in a spreadsheet a little better. So the invalid count case, they should be equal. Good, 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 good. Ooh, and then this is, we'll leave this the way it is. All right, so this is saying, so this will be false if I am at last, so this better be true that I wrapped. Otherwise, this will be false when I'm not at last, and so this should be true. Okay, good. So I will call this, bound 0. We'll call this bound I. So overflow. Wow, how did I do that? So theoretically, all right. Now I got my symmetric cases here. I'm going to do the same thing where we try and line these up. All right. Yeah, so I changed the number of characters in it, so it's not quite lined up. Okay. So now we have the overflow increment case. Cool. So this is just saying that if this is not last, then I should overflow. Okay. So now I have these special guys. All right, so I think this is, so if I minus 1 is at last, so in, let's see, so what we're saying is, okay, so if I minus 1 is not at the last, on the last count, then I better stay the same number. But if for some reason it is at the last count, then I better be plus 1. All right. So we'll call that inc R and inc S. All right. So I think that's the test that we need. Fun. So it seems like I did something hinky around line 84. Whoa. So I forgot to actually put the loops in to iterate over. So one of the ways that you might do this differently, you might write it like this. And then now these become $unders. So we'll do that just to show you how that works. So it's a little less typing, or a lot less typing. And then I think it's an inclusive bound, so I think I need to subtract the 1 to get it to behave the way I want. But we can. Verilog will yell at me if I screwed up the boundary. Token is end. So 142, yeah, we forgot a semicolon. Oh no. So, how was it angry at me this time? So it looks like our fancy new test is not So let's see, which test is failing? So it seems to be this count. So they're doing something weird with parens. Are those, oh, they're just showing what that looks like. So any of these not less than, okay, so at the very beginning we have some less than equals, and then, do we ever get that again? So it looks like at the very beginning we have some issues where if we're not quite there, it's going to be mad at us. So I think reset's supposed to be low when that's running, so it should have trivially passed. Right, is that this test should have just passed. Like all the other tests, because it doesn't matter. You know what? And then let's make our lives a little easier, because we do have this signal that'll tell us if our count is valid. So let's see. That should get rid of that probably. And then we're having, is it always index 1 or is it, yeah. So these all, so what I'm doing right now is I'm just trying to make sure that it's the same test running over and over again. So, I think if we just look for something like this, we could say, okay, is it this guy? Roughly looks like it's the same one. So what we'll do is, I think it's minus L, tells me how many there are. So what we're interested in is how many of those there are. I just want the number. So 47,000. So then it looks like there's a few more that are not that. All right. So these are bound and valid. So let's see. So what if we do grep minus n So it's probably faster to just do this. And I suspect that, you know, if we do a three-dimensional version, there's a problem here. All right. And then we'll test the new. We should probably start cleaning up those lints at some point. So now, which one is it upset about? All right, so now it's upset about INCS1. So regardless, oops. So let's double check that this makes sense. And then did we fix our zero time issue? We did not. All right, so we're just going to turn those off for now. So let's turn off these for now too. See if we've identified all of the tests that have issues. Ah. So Susanna is pointing out on the two valid lines, am I missing semicolons? So I think the semicolons are right here, right, so that's valid, that's valid. So there is a semicolon missing there. That's interesting. I wonder why it didn't pick that up. Super interesting. Good catch, Susanna. Yeah. So it's interesting that it didn't flag that as a syntax error and yell at me right away. So bound one is mad about that. Looks like they may all be bound 1. Alright, so let's try commenting out that one. Alright, so did I... Wow. And bound 0 apparently was upset about that in a few places. So what I'm doing right now is I'm trying to just figure out what all of the ones that have a problem are, so that then I can turn them all on one at a time and then fix them. All right, so it looks like every one that we've added is broken. And I'm, for some reason, so this one still works because that's the invalid count case. So if we're not incrementing or it gets stuck, all right. And it looks like we only had one of these. So valid 0. So this is probably a good one to start with. And then I'm a bit worried about these bound cases, that those seem to be failing. And then this reset issue, is interesting. All right, and then let's make sure that it looks like I think it looks like. Yeah, that's what it looks like. The semicolon there. All right, so that looks good. No. All right, so we fixed most of those. So then the question is, all right, so I think we'll roughly do it like 1, 2, 3, 4. This should be easy. No, that should be hard. This should be easy. This should be easy. This will be the last one we do. All right. So, unfortunately, schedules are a bit tight today. So I'm not going to be able to stick it out a little bit longer like I normally would. So what we're going to do next time is finish fixing the tests. Uh-oh. What did I do? Oh, okay. Okay, 1, 2, 3. Yeah, this is probably 3. This is probably 4. 5, 6, 7. All right. So we need to fix the tests. Fix them in numerical order. And then run some trials in 3 dimensions just for fun. Cool. So that's going to be it for me today. This was not as... This is some of what I spend a little bit more time than I should working on when I'm doing some of these designs, is trying to get all the assertions kind of set up, because they do a pretty good job of providing an alternate perspective on what's supposed to happen. And methodologically, if you're kind of stepping back and trying to guess what I'm doing here, the idea is I'm trying to write unit tests for low-level modules so that as I kind of accrue them, things go better. Right, so we've sort of verified our bounding box thing and our clamp thing, and now we're verifying our little counter. So when we build a bounding box iterator, hopefully on the next session, we're kind of guaranteed that if there is an issue, it's because the things are interacting weird, not because they are individually weird. Well, thanks for joining me, guys, and I will be back next time for session 6 to keep the iterator going. Have a great night.